possibility that the switch variable will not correspond to any of the case labels, and thus you'll quote-unquote fall through the switch case construct without doing anything. And that is also a branch. And the reason that I'm belaboring this point is it is very important to remember, because this point is something that a lot of people get confused about. But it is a key thing to keep in mind, because it's easy to not test certain important things by forgetting about the fact that just because there's not a if block defined or a default block defined, that doesn't mean that there's not something interesting that could happen if you hit them. Now, condition coverage. The decisions are typically made based on conditions. In pretty much every programming construct that I can think of, there's some idea of a condition that's going to evaluate either true or false, or in the case of the switch case block, there's a equivalency that's being checked, and that's a true or false check that's happening there as well. So the condition coverage says that we identify every atomic condition in the program, and we make sure that that has been evaluated once to true and once to false. Now, when I say atomic condition, what I mean by that is that if you have a compound condition, like if A greater than B and C greater than D, then both the A greater than B and the C greater than D have to be evaluated both true and false. Now, that leads us to multi-condition coverage. When you have compound conditions, not only do you want to get condition coverage possibly, but you also want to get multi-condition coverage. And multi-condition coverage is saying, I want to test every possible combination. So in condition coverage, we say, go back to the previous example, both A greater than B and C greater than D had to be both true and false. But in multi-condition coverage, we say, no, we want to test all four combinations. We want to test true, 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 false, false, true, and false, false. So that's what's happening there. You're testing all possible logical combinations. And since it's going to be defined on something that's Boolean, then the number of tests is going to be 2 to the power of however many atomic conditions there are. So either 4 or 8 or 16, what have you. Now, in multi-condition decision coverage, we back that down a little bit, and we say, well, some of these condition combinations cannot actually affect the decision that occurs. So, for example, and we talk about if A greater than B and C greater than D, if the first condition, the A greater than B, evaluates to false, then most optimizing compilers will simply stop execution, and it will not check the second condition, because it doesn't matter at that point. The overall condition has now been evaluated. It's going to be false and compound with an AND. So instead of having to test 4 combinations in these situations, you would test 3. You would only test those combinations that would actually result in some evaluation of the subsequent conditions. So if you got to the point in the evaluation of conditions where any subsequent condition could not affect the decision, then you stop evaluating. And then finally, we have loop coverage. Now, in loop coverage, ideally you would try to cover all possible loop paths, but that's generally impossible. So usually the idea is to cover 0 loop paths. In other words, not executing the body of the loop at all. Once, in other words, executing the loop body exactly one time, once and only once, and then multiple times, and ideally that would be the maximum number of times. Now, some cases the maximum can be squishy, if you will, because the program is looping on some sort of condition that's determined by the real world, and then it can go on, forever, basically. I mean, for example, like event-driven programs, they just sit there in a basically infinite loop, waiting for events to occur until something causes them to terminate. So, how many events can Word, for example, respond to in the course of a single usage session? Well, it's not really possible to say. But in loop coverage, we would want to get a very large number of loop iterations, something that would potentially be stressful for the system. So let's take a look here. We have a simple example here. As one of you noticed at the very beginning of this presentation, is the Fibonacci program here, or a Fibonacci program. It generates a Fibonacci series using a loop. So we're going to ask first for the number of elements, and we're going to read that in, and then we're going to, if the number of elements requested is invalid, we're going to give an error message. Otherwise, we are going to print the Fibonacci series inside of a pair of curly braces, and it's going to loop around and generate the elements of the series and print them out one after the other, and then it'll exit. So in order to get statement coverage, notice that if we test with n less than 0 and n greater than 0, we will execute every one of the statements. So if we take negative 7, for example, let's go ahead and highlight this. So if we take negative 7, then we go here and we get this, and do that piece there, and then since we're less than 0, we're not going to do the body of the else, so we're going to go down here, and we're going to exit, and out we go. Now, if we then test with, say, 2, we would come in here again, and we cover this again, we get here, and then we go, okay, we're going to do the else. We come down here, and we loop around this loop a couple times, and then we exit, print out, and then we exit. So as you can see there, every statement got painted, if you will. Now, the question next here is, well, did that get us branch coverage? And there's a little bit of controversy about this, but my answer is no. My answer is that you would have to test with n equals 0 to also get branch coverage. Now, why do I say that? Well, it's because basically a loop has to be thought of as a form of a branch. It is an interesting form of a branch where it is directing the control flow back upstream as long as certain conditions are met. And then if not, it's directing the control flow around the loop body to the subsequent code if those conditions are not met. So it is a branch. It's just a branch that happens to iterate its body. And it's also, if that's not a convincing enough argument to you, for those of you who've gone through a computer science program, think about how the loop is ultimately implemented in the assembly language down at the guts of the computer. I mean, it is basically the same mechanisms by which a branch is created. There's no difference. So since what we're trying to do is test the program based on the way the program actually works, since a loop is implemented using the same constructs that are used to implement a branch, it seems to me nonsensical to argue with branch coverage doesn't apply to loops, though you will sometimes see people making that statement. Anyway, my opinion is that you would have to test with n equals 0 to not test the body of the loop once in order to get the branch coverage. Now, will this get us condition coverage, multi-condition decision coverage, multi-condition coverage? Yes, in this case it does, because there are no compound conditions. So you have to have compound conditions for